Hi everyone, and welcome to another part of the blockchain tutorials. In this part, we're going to get started with Hardhat framework on the Ethereum blockchain. So Hardhat makes it easier for you to run, compile, deploy, and interact with your smart contracts. Notice that previously we used web3.js libraries, and notice that Hardhat is based on these libraries, but it's a framework that makes your process much easier, makes it much easier for you to run, compile, deploy, and interact with the smart contracts without ever needing to write so many lines of code. So all you need to do is to run compile on your terminal, and it will compile your project without ever needing to write the compiling task or lines of code. So here on the Hardhat website, there are some documentations in order to get started with a Hardhat project. Notice that the tutorial that we're recording right now might be outdated at the time that you're seeing this video. So all you need to do is to head over to the hardhat.org and head over to the documentation, and here you will be able to see the guidelines and the commands in order to get started with the project, and then how to set it up, how to write the code, how to run and compile the smart contracts, how to interact with them, and so many other things that you can do with the smart contracts in order to create your own decentralized application. So what I'm going to do here is to create a sample project using Hardhat. Notice that Hardhat is one of the most popular frameworks on the Ethereum blockchain and other blockchains as well. So with Hardhat, you don't necessarily need to use web3.js. Notice that we also have Truffle, which is nearly the same as Hardhat, but Hardhat is more robust and popular amongst the blockchain programmers. That's why we have chosen to work with Hardhat. So right now, in order to create a project using Hardhat, I'm going to open my terminal. So I will open the terminal. You can use the VS Code terminal. So make sure you create your project at a specific folder so that you can have a management on the project later in the future. So the first command is just like any other JavaScript or Node.js command. So all you need to do is to run npm init-y, and then it will create a project for you, which is which contains just package.json. So right after that, you need to install Hardhat. So in order to do so, you need to install npm install --save and -dev Hardhat, and then make sure that you install Hardhat first, and then we will be able to get us started with the project. So right now the installation has got completed. So in order to continue the rest of the process on the VS Code, we can write code space dot, and here we'll open VS Code for us for this project folder, and then I'm gonna open it up, and here let's open a terminal in order to continue the rest of the commands. So what I'm going to do here is to run npx hardhat, and now we can create either JavaScript project, TypeScript project, empty hardhat.config.js, or quit. I prefer JavaScript project, so I will click on it, and it will ask me for the project root. The default is okay. So now it asks us whether we need .gitignore, which is highly recommended. So I will enter Y or click enter to confirm yes. So do you want to install this sample project's dependencies with npm? So there are a number of dependencies for Hardhat which you need to click enter, and then it will install the dependencies for us. And now after the completion of the installation, the project is successfully created, and then we can continue with the rest of the process on the Hardhat project. So right now we can take a look at the project that has been created. We have a script containing the deploy.js code, which is ready for us for the sample smart contract that has been placed on the contracts folder. So whatever kind of a smart contract that you will have, you can place it on the contracts folder. Here there is a default smart contract called lock.so. Let's open it up. Notice that this smart contract shows you how you can lock your assets on a specific address and then make it unlock that asset later in the future. The use case of this smart contract is that if you want to hold an asset for a specific amount of time, or make it available for yourself, or I don't know, somehow deposit it somewhere and use it later for any other purpose that you will have, you can use this smart contract, and it helps you hold that specific asset for a specific amount of time. So here it's we have defined the unlock time, the owner, and the withdrawal, which is the event for withdrawing the asset. So it gets the amount and the time that we will release the asset or unlock it, and then we will have a constructor which gets the unlock time, and here we will require some kind of condition here for the block.timestamp to be less than the unlock time. Otherwise, it will show unlock time should be in the future, so you cannot unlock the asset. So then we'll get the unlock time from the user at the time of the deployment, and the owner, who is the message sender, right? So this is also useful for someone who wants to let somebody else have the access to a specific asset sometime in the future, and it may have a lot of use cases. So the function of withdraw is for withdrawing the asset, and it's a public function. So it will first require that the block.timestamp be greater than the unlock time. Otherwise, it will show that you cannot withdraw yet. It also requires that the message.sender be the owner. So in this way, only the owner can will be able to withdraw the asset, and nobody else can. So this requirement is really important, because otherwise other people can withdraw the asset, and the asset will not be safe. So it says that you aren't the owner. So this is a really important statement here. And then what it's going to do is to emit the withdrawal. After we pass these two conditions, then it will emit the withdrawal event, and the address of the owner balance will be inside of the withdrawal event, and the block.timestamp as well. So after that, the final step is to transfer the ownership to the person who owns the tokens or the assets, and then the balance of the owner will change. Anyway, that's it for the smart contract. So this is a useful smart contract. This could be an example in our tutorials. So first of all, I'm going to make you familiar with the structure of a Hardhat project, and in this way you can see the very first project that has been created here in this project, and where to place your smart contract for the deployment. And notice that the necessary modules and dependencies are installed instead of the node modules. They're placed in there. So if there are any further libraries that you will need to install, for example OpenZeppelin, you can install it using npm, and it will be placed inside of this folder. Right now we have nothing to do with this node modules, and I will go after the deploy.js. Here the deploy.js code will let us deploy the smart contract. And notice that there is something much more important here that I need to mention at the beginning, is that the hardhat.config.js, which is the most important part of every Hardhat project. Here there are some of the options that you will need to determine here: the version of Solidity, which in our case most of the time is 0.8.0, but here for this smart contract it is 0.8.19. Here, as you can see, it doesn't have any contradiction with the version here. However, they're not the same. They will be able to be compiled without any problem. So you should be able to set these two versions and make them work together. If there are problems with the version, then you will need to install another version of Solidity here, or Solk, which is the Solidity compiler for the Hardhat. So Hardhat will let you know if you need any other version of Solidity. So for example here, if we don't have the 0.8.9, Solidity will install this for us automatically at the time of the compilation. So right now there is no code, as you can see, there is no code for compiling the smart contract, but Hardhat does this internally. So all you need to do in order to compile a smart contract is to run a very simple command, and the command here to compile is npx hardhat. Oh, I shouldn't write it here, I should write it in the terminal. Anyway, let me fix this. npm hardhat compile, and just as easy as that, you'll see that Hardhat will get installed. But here it seems that there is a problem with note. Oh, here I should have used npx instead of npm. So right now npx in Hardhat compile, and as you can see, just as easy as that, compiled one Solidity file successfully without ever needing to write even one line of code. Hardhat does this so easy for us. So if you remember from our previous tutorial, we had to run just about a function containing 10 plus lines of codes in order to compile a smart contract, but using Hardhat, this job has become much easier and faster for you, and you don't ever need to use those lines of code using web3.js. Here using Hardhat, the job will be done successfully. So right now the next thing in order to compile the smart contract is to here run npx hardhat run a script, the deploy.js script on the network of the Hardhat. So here we have a network called Hardhat, which is built in the Hardhat framework, and it's a kind of a simulated blockchain like Ganache, or it's a local blockchain, so you don't necessarily need to use testnet or Ganache. Here you have the Hardhat simulated blockchain. Or you can add your blockchain, your kind of blockchain that you want to work on, whether it's Ganache or Ganache CLI or testnet. You can add it right over here inside of the hardhat.config.js. I will teach you in the later videos, but right now let's become familiar with the workflow on the Hardhat framework. Right now, let's run npx hardhat run scripts, and here we'll define we'll determine the root of the directory of the deploy script. So here on the scripts folder we have the deploy.js, and then we should determine the network that we want the smart contract to be deployed on, and the network here is Hardhat. So Hardhat has a built-in network that you can easily simulate a blockchain and run your smart contracts on it. So once we run this, as you can see, just as easy as that, the project has been deployed, and also we interact with it. So we logged 0.001 if an unlocked timestamp is this time. You can convert it in the epoch converter on Google and test what this time is right now and how much time is remaining. So this a smart contract is deployed to this address. This is also the address of the deployment. So just as easy as that, we've had the smart contract compiled and deployed and interacted with. So I will teach you about the further projects adding to the Hardhat framework, and how to work with other networks, and how to compile your smart contracts, how to change the Solidity version, and all other questions that you have in mind. But it's notice that right now this tutorial video purpose was to make you familiar with the Hardhat framework, the commands that you need to use, and how easy it is to work with in order to create your own decentralized application. So that's it for this tutorial, and until the next one, goodbye.